Great. Well, thank you for attending today's Training on the T's webinar. My name is Ginger Grant, and today I'm going to be talking about Hadoop. As this is an introductory webinar, one of my goals is to provide a broad understanding of the topic without adding too much mind-numbing minutia. To start out with, we're going to talk about the elephant in the room. Metaphorically speaking, it isn't really an elephant. It's generally an unaddressed, overwhelming issue that everyone knows is there, but for some strange reason is never addressed and stays in the category of things which shall not be named. I'm sure nearly everyone attending has heard about big data, specifically Hadoop, because it's written up a lot in the trade press. Given that Pragmatic Works is a Microsoft partner, I'm guessing there's a lot of people listening who have a background in SQL Server like I do. I think that the obvious thing that we're going to start talking about is the impact of Hadoop on what you may be asked to write in the future, as I'm assuming many people listening have been working for a while on relational databases, including SQL Server. Based on some of the conversations that I've had, there's some people who think that big data and Hadoop are going to make SQL Server and relational databases the next VB6. After looking into the topic, I don't think so. There are some things that SQL Server and other relational databases do very well. And for that reason, relational databases are not going to go away. There are problems that they're really good at solving. Based on why Hadoop was created and what it was designed to do, there are some things that Hadoop is much better at doing than relational databases, especially if you're talking about unstructured data. But for this reason, both tools are needed, as they both have jobs to do. And today, I'd like to provide you a background into how and why Hadoop was developed, so you can better understand where and how to use it, and how it's changed since it was first developed, and what you can do to get started using it yourself. So now that I've caught your interest a little bit, I'll blather on a little bit about myself. My name is Ginger Grant, and I work for Pragmatic Works. I have an MCTS for SQL Server 2008 and MCSA in 2012, which would lead you to believe correctly, I do not have a background in Linux or Java. I am and have been consulting in Microsoft Business Intelligence Development for a while. But all my interest in data has made me look at, Hadoop and larger data and big data. And as anyone is interested in technology, I tend to talk about it quite a bit in the community at SQL Server Saturdays, code camps, and other webinars like this one. I tend to write about my interests online, which is where you can find out where I'm speaking next. I tweet at Desert Isle SQL, which is a great way to ask me any follow-up questions you might have after this. And I have a blog where I've got more information regarding Hadoop and other data topics that I'm interested in. And of course, I've got email. So to better understand Hadoop, I think it's important to know a little bit about the history behind it. In the 90s, Stanford started doing some research for the government on how to provide better access to all the data they were accumulating from satellites and missile systems, among other intelligence gathering. So there was a lot of research done to how to solve their big data problems. Coincidentally, the founders of Google came from Stanford too. Let's face it, the search engine is a good model for talking about big data. Someone has some data somewhere on the web, you type in a few words, and a list of web pages comes back. This is what Hadoop was built to do. You can't talk about big data without talking about Google, because that's where it all began. So in 2003, Google was having some problems with their original plan to index their search engines. They were running Oracle, and as we know, Oracle is expensive. They didn't spend as much money as they needed to spend on hardware, and they're having problems with the machines crashing. Funny to think of Google being short on money now, isn't it? Indexing was taking too long, and they couldn't keep up with it, so they needed a solution. So they came up with two methods to address these issues. To resolve the issues around hardware, they stored all the data in a redundant file system that they called the Google file system. So they would be okay if a server crashed, because the Google file system writes the data a minimum of 3 different times. To get the data out, they quit using Oracle and their indexing and started to use a reducer program using C++ to access the data. In 2004, Google published a paper on how their proprietary technology allowed to store their data redundantly on cheap hardware and retrieve it the right way quickly when someone types something into a search engine. At about the same time, about 2002, 2 other Silicon Valley software engineers started working on a search engine of their own called Nutch. Obviously, you've probably not heard of it either. It's an open source search engine. Both of them are really big open source advocates. You may have heard of these two guys. Their names are Mike Caffarella and Doug Cutting. And they read Google's paper and they started working on an open source version of Google's ideas. Yahoo was also extremely interested in this technology, so they hired Doug Cutting to work on it. So he and Mike Caffarella, and Mike decided to quit Silicon Valley to pursue a PhD at the University of Washington at the time. They went on to develop Hadoop, which was named after Doug's kid's stuffed toy. And here's the original Hadoop that the language was named after. And here's a logo today. Hadoop incorporated Google's proprietary file system and language to create the same thing with Java and open source. Hadoop and MapReduce. Hadoop is open source and it's got a whole lot of contributors, and the code base is controlled by Apache. So basically, if you really want to learn about Hadoop, you need to go to apache.org, as that's where the source of all the information of stuff that's been released and stuff that they're working on. That you really need to check out their website. So since I have, I'll just tell you what is Hadoop. Well, it's an indexed file system used for storing and retrieving data. HDFS, the Hadoop file system, is a slight modification of what Google came up with to store the data. It's data stored in large redundant blocks with a name node to index these blocks. Thinking back to the history of when this was created, when Google came up with the file system, they had inexpensive hardware. Like a lot of things, when you buy the cheap stuff, it tends to break. Google ran into this problem, so they created a file system which wrote the data more than once, so if the hardware broke, they'd still be up. The HDFS file system stores data in big chunks, from 64 to 128 meg, generally speaking about 3 times. Just a bit of comparison, SQL Server uses 8K storage pages for its data, so there's a big difference there. The index which keeps track of the location of those blocks is stored in a name node. So MapReduce is used because once you have the data stored, it's important to get it back out, which is what MapReduce is designed to do. MapReduce is a batch process, which means you got to write some code to get the data out. The code is written most often in Java, although Microsoft does have an implementation in HD Insight where you can write C# code instead. So, but one thing that Hadoop was not designed to do